Good morning, children. The last class we discussed about moving galvanometer, so that construction and working and how the formula of twist is matched with the torque. Everything we discussed. So torque எப்படி கிரியேட் ஆகும், ஸோ நம்ம அதை எப்படி மேட்ச் பண்ணியிருக்கோம் கப்பலோட, அதெல்லாம் நம்ம பார்த்தோம். ஸோ how to find out the current using that moving galvanometer we discussed in our last class. So following that, and today we will start figure of merit of a galvanometer. So this figure of merit of a galvanometer, it is nothing but the current required to produce a reflection of one scale division in the galvanometer. So how much current we require to produce one scale reflection in the galvanometer? This is called as figure of merit of galvanometer. So in that we have sensitivity of galvanometer, and we can say the galvanometer having the good sensitivity when it's showing the large deflection for a small current. It's showing the large reflection for small current when it's passing through that. This is called as sensitivity of a galvanometer. And now we'll define current sensitivity. It is defined as the reflection produced per unit current. So the current sensitivity is defined as the reflection produced per unit current when it is flowing through the galvanometer. This is called as current sensitivity, and that formula we can write as IS is equal to theta divided by I. So here theta and I from the moving coil galvanometer derivation. So in past class we discussed it. Just to check that equation, using that we are substituting here, then the answer will become NAB divided by K. Then we can write IS is equal to I divided by 1 divided by G. Okay, this is the formula we are getting for sensitivity of current. And current sensitivity of galvanometer can be increased in following 4 ways. One is we can increase the number of turns, that means capital N, then the current sensitivity increases. The next one is B, magnetic induction. When we are increasing, that current sensitivity increases, then area of the coil, the contacting area increases, the sensitivity is also increases. The last one is decreasing the couple per unit twist. It is opposite, so it decreases, the sensitivity increases. So these 4 things we are using to increase the current sensitivity. Next one, phosphor bronze wire is used as a suspension wire because it produces the couple per unit twist is very small. It's a production of couple per unit twist is very small. That's why we are using phosphor bronze wire in this moving coil galvanometer. எல்லாமே ஞாபகம் இருக்குன்னு நினைக்கிறேன். Next is voltage sensitivity. It is defined as the reflection produced per unit voltage across the galvanometer. The reflection produced per unit voltage across the galvanometer, this is called as voltage sensitivity. Then we can write with the formula voltage sensitivity Vs is equal to theta divided by V. And again we are going to use the moving coil galvanometer derivation equation, and before that here we are substituting the Ohm's law derivation. What is Ohm's law? At constant temperature, the potential difference is directly proportional to current in the particular conductor. So V is equal to IR. So here it is about galvanometer, then the resistance will be taken as Rg here. Then we are substituting V as, see this V is substituted as Rg in next step. Then here this equation we are deriving from moving coil galvanometer derivation. Then we are getting the answer Vs is equal to 1 by G Re, or we can write Is divided by Re. Okay, because this G we can substitute from this, so we are substituting this step here. G is equal to what? 1 by Is. Then here we are substituting G 1 by Is from this equation 3.72. Then we are getting the equation 3.73. The equation Vs is equal to Is divided by Rg. Okay, so here Rg is nothing but a resistance of galvanometer. So this is we are getting from the voltage sensitivity. And next example 3.25. So in this more 2 mark questions are there. First we will mark this 2 mark questions, and all are important questions. So figure of merit of galvanometer definition, then current density with the formula definition, then how we can increase the current sensitivity in a galvanometer, these 4 points, and why we are using Pasco bronze wire. That is another one, 2 mark question. Then voltage sensitivity, we can write, we can mark with this formula. So all these questions are 2 marks. I hope you know how to mark and study in this. Okay, so after that voltage sensitivity, now we are moving to example 3.25, and here there is a question. The coil of a moving coil galvanometer has 5 turns. So number of turns are 5 here. And each turn has an effective area of 2 into 10 to the power minus 2 m square. Okay. And it is suspended in a magnetic field. The strength of the magnetic field is 4 into 10 to the power minus 2 Weber per meter square. If the torsional constant value is 4 into 10 to the power minus 9 Newton meter per degree, means here there are some 3 questions are placed. First one, find its current sensitivity in division per microampere. And second question, we have to calculate the voltage sensitivity of a galvanometer for its to have full scale reflection 50 divisions for 25 millivolts. So 1 milli is, we know, 10 power minus 3. Then compare the resistance of the galvanometer. So all the given data are noted here in solution. So we are going to find out the current sensitivity from the previous topic. We can use the formula I is equal to NAB divided by K. So everything is there. We are substituting. Everything is given in question itself. We are solving. So while solving, 10 powers are separated and 10 powers are combined. Then rest will be combined. After the combination, we are getting the answer 10 power 6 divisions per ampere. இந்த ஸ்டெப்ஸ் எல்லாம் உங்களுக்கு நான் ஒர்க் அவுட் பண்ணி காட்ட வேண்டியதில்லைன்னு நினைக்கிறேன். ஸோ லாஸ்ட் இயர் நம்ம நிறைய டைம் பண்ணியிருக்கோம். அண்ட் யூ ஆர் ஆல் குட் அண்ட் யூ ஆர் ஆல் ஃபெமிலியர் வித் திஸ் டெரிவேஷன்ஸ். ஸோ ஈஸியாக நீங்களே ஒர்க் அவுட் பண்ணிடுவீங்கன்னு எனக்கு தெரியும். ஸோ டவுட் இருந்தால் ஜஸ்ட் வில் டிஸ்கஸ். அண்ட் நவ் தட் கொஷின் இஸ் இன் micro. So micro or micron, which having the value of 10 power minus 6 is given. We have to say in micro. So to say the micro, IS is written here, IS equal to 10 power 6 division per ampere, and that 10 power 6 will goes down, it will become 10 power minus 6. So 10 power minus 6 ampere is nothing but micron. 10 power minus 6 is what? Micron. இதுவும் நம்ம லாஸ்ட் இயர்லேயே டிஸ்கஸ் பண்ணியிருக்கோம். So IS we can write as 1 division microampere. Okay, and next is voltage sensitivity. This is direct substitution. We'll get the answer directly. So that is a formula from the previous topic. Vs is equal to, we can substitute as theta divided by V. That is 50 divided by 25 millivolts. And here 1 milli is what? 10 power minus 3. About 25 to 10 power minus 3 நம்ம substitution பண்ணுவோம். That 10 power minus 3 will goes up. 50 by 25 is what? 2. Then 2 into 10 to the power 3 division per voltage. This is the answer for voltage sensitivity. Then third one is the resistance of the galvanometer. Here the question, this substitution is from Ohm's law. V is equal to IR, and in that method we are substituting here RG is equal to IS divided by Vs from the Ohm's law. Okay, V is equal to IR. Then what is R? V divided by I. அதை நம்ம இங்கே சப்ஸ்டியூஷன் பண்ணியிருக்கோம். Then IS divided by Vs. Then we are substituted. After solving, we are getting the answer as 0.5 kilo ohm. This is what? This is resistance. Okay, so hope you have understood this simple derivation. In the derivation எதுவும் இல்லை. If you thorough with the formula, it is very simple. Easy நீங்கள் ஒர்க் அவுட் பண்ணி ஆன்சர் ஃபைண்ட் பண்ணலாம். If you have any difficulty, just will discuss separately through WhatsApp. Okay. And next is example 3.26. The question is, the resistance of a moving coil galvanometer is made twice its original value in order to increase the current sensitivity by 50%. Then they're asking, find the percentage change in voltage sensitivity. We have to find out the percentage sensitivity, percentage change in voltage sensitivity, and we are starting with the solution. Voltage sensitivity Vs is equal to Is by Rs. Once again, we are getting the help from voltage sensitivity equation that we derived previously. When the resistance is doubled here, then the resistance can be written as 2 times of resistance. Okay, and current sensitivity we can write as 50 percentage, then 1 plus 50 percentage. 50 percentage means 50 by 100 of is. That solve is gives the answer 3 by 2 is. And now the new voltage sensitivity is Vs dash equal to 3 by 2 is divided by 2 Rg, so 3 by 4 Vs. Hence the voltage sensitivity decreases, the percentage decreases in voltage sensitivity. Then we can write Vs minus Vs dash, that will be Vs into 100 percentage. Then the answer will become 25 percentage. So the answer here, the voltage sensitivity of the galvanometer here is 25 percentage. So it is clear from this answer. Okay, and now we are moving to next topic. It is an important one, and we are at the end of this unit number 3. Okay, and the topic is conversion of galvanometer into voltmeter. Conversion of galvanometer into voltmeter. Then we will discuss about ammeter. Sorry, voltmeter. Then we will discuss about ammeter. Then voltmeter. So a galvanometer is a very sensitive to measure the current. With the help of two ideas, we can convert galvanometer into ammeter and also galvanometer into voltmeter. So how to convert? That we'll discuss in this topic. So first we'll discuss about galvanometer is converted into ammeter. So this is a device, ammeter, which is used to measure the current flowing in the circuit that we are going to measure here. So to convert that, we are following the method. So just to remember this, it is not for examination, just for your remembrance. So galvanometer first letter is G, and we are converting the galvanometer into ammeter. Then you write next letter as A. For that we have to use LP. So remain as GALP. Just remain பண்ணதுக்கு வெச்சுக்கோ. GALP. Galvanometer is converting into ammeter by the method of low resistance in parallel connection. Okay, இதை மைண்டில் வச்சுக்கோ. This is the method and this is the idea how the galvanometer is converted into ammeter. So that is given as the key point. எக்ஸாம்பிள் பார்த்தீங்கன்னா இந்த பாயிண்ட்டுக்கும் ஹைலைட் மார்க்ஸ் கொடுத்துருப்பான். ஓகே, கீழே இந்த பாயிண்ட்ஸுக்கும் மார்க் கொடுத்துருப்பான். ஸோ திஸ் இஸ் இம்பார்ட்டன்ட் பாயிண்ட். லோ ரெசிஸ்டன்ஸ் is parallel with the galvanometer that is converted into what? Ammeter. Good. And now about the diagram figure, and here we are using two resistances. One is S shunt resistance, next one is G galvanometer. This galvanometer is also acting as resistance. It offers some resistance here. Okay, and here the galvanometer and shunt resistance both are parallel to each other. Galvanometer and shunt resistance both are parallel to each other, and we are passing the I current to the circuit, and this I, when it reaches to the point A, it splitted as Ig and I minus Ig. Ig is traveling towards G, I minus Ig is traveling towards C. Then it passes S, then D, then it will be reach E. After E, Ig and I minus Ig combine together. Once again it forms as same current I. Okay, the path of I minus Ig is ACDE. The path of I minus Ig is what? ACDE. And the path of Ig is AE. So that is discussed here. We know when in a circuit, electrical circuit, if it is parallel, the potential definitely will be same. இது நம்ம செகண்ட் யூனிட்லயே நம்ம படிச்சிருக்கோம். அப்போ சீரிஸா இருந்துச்சுன்னா the current will be same. Okay, here the potentials are same. Then we can write the formula V galvanometer is equal to V shunt. So how we can write here? V galvanometer is equal to V shunt. We can write once again Ohm's law formula. V is equal to IR. Then we are writing IGRG is equal to I minus IG of S. Then finding S, IG by I minus IS of RG, or we can find IG is equal to S by S plus RG into I. So this step we can derive like this following method. See here, the equation after this we can write like this. So S is equal to Ig by I minus Ig of Rs can be written as invert method. You send the Rg to left hand side, it will become Rg. Okay, and you write first invert 1 by I 1 by S, then I minus Ig by Rs. It will come. Then in reciprocal we can write Rg by S, and this I minus Ig divided by Ig will come in reciprocal method. So we are writing in this step. And see the next step, we are splitting this term I by Ig minus Ig by Ig. So I by Ig, Ig by Ig will become 1. That 1 will goes left hand side. It will acquire 1 plus Rg by S, that is equal to I by Ig. So taking LCM this step, Rg plus S divided by S, that is equal to I by Ig. Then we, using the cross multiplication, Ig will comes left. Then Rg plus S divided by S will goes right. Then we will get this equation. Now the current flowing through the galvanometer, we can measure with the formula S divided by S plus Rg of I. So this is the final equation we got using this derivation. So hope you all copy this derivation in your textbook. Pencil எடுத்து இந்த derivation copy பண்ணிங்க. And here the reflection of the galvanometer is proportional to current passing through it. Then we can write theta is equal to 1 by g Ig. It is proportional, then we can write theta is proportional to Ig, or we can write theta is proportional to I. So we can write the reflection produced in this galvanometer is measured of the current I passing through the circuit. So in this way we can calculate easily about the current flowing through this ammeter. And here we are using the shunt resistance. It is parallel to the galvanometer. So the resistance can be defined with the help of the formula which we discussed in unit number 2. It is parallel. Then we know the formula is 1 by Rp is equal to 1 by R1 plus 1 by R2. இது உங்களுக்கு எல்லாத்துக்கும் தெரியும். இங்கே effective is taken as 1 by Rf, and 1 by first resistance is 1 by Rs plus 1 by S. Okay, sorry, 1 by Rg. Then taking LCM, then reciprocal, the equation will become Rgs divided by Rg plus S. And since the shunt resistance is very low resistance, the ratio S by R is also small. It means the RA is also small. Okay, and we can write this percentage, say the ideal current measured by the ideal ammeter, and I current which is passing through this as actual current in the circuit. We can calculate here delta I divided by I into 100% is equal to I ideal minus I actual divided by I ideal into 100%. So from this we can measure as a percentage error. And here while handling this ammeter we have to follow some key points. One is an ammeter is a low resistance instrument. It is also connected in series to the circuit. While connecting in the circuit to measure the electric current, this ammeter should be connected in the series. And we can use ideal ammeter which having the zero resistance. And third point is, in order to increase the range of an ammeter for n times the shunt resistance to be connected in parallel, then the formula will become S is equal to Rg by n minus 1. That formula we are. So these three key points we have to keep in our mind while handling this ammeter. So here galvanometer is converted into ammeter. So in this we have to keep these points, these important points while handling this ammeter. Okay, and now we'll mark question answer for this 5-mark question. This one is important 5-mark question. So galvanometer is converted into ammeter, and this answer is extends up to the 3 keys. Third key before the galvanometer in page 185, before the galvanometer to voltmeter. So up to S equal to Rg divided by n minus 1. This answer for this galvanometer is connected into ammeter with the help of low resistance which is connected in parallel. Okay, and also in this important, this ammeter should be connected series with the electrical circuit. அது நமக்கு எல்லாத்துக்கும் தெரியும். Then in the last question, இப்போ மார்க் பண்ண 5 மார்க் கொஷினை கேலமெண்ட் இன்ட்டு அம்மீட்டரை you can take as a homework question. Then you thorough this with the diagram. இந்த டயக்ராமையும் இன்க்ளூட் பண்ணிக்கோ, அண்டர்ஸ்டாண்ட் பண்ணி write every theory parts as a homework test. Then you send that image to my personal WhatsApp number. Okay, thank you children.